Hi, thanks for clicking on this video and welcome to episode 15 of my Arduino tutorial. In today's video, we'll be learning to program the Common Cathode and Common Anode RGB LEDs in the simplest way possible. I'll make it as easy as possible, do my best to explain it as much as I can. And this is probably going to be a long video, so without much further ado, let's get straight into it. If you don't know how the Common Anode and Common Cathode RGB LEDs work, you can check out my previous videos where I explain it in detail. Now, let's focus on the Common Cathode RGB LED first. The longest leg of the Common Cathode RGB LED is the ground pin. To the left of it, we have the red pin. To the right, we have the green pin. And next to the green, we have the blue pin. The simplest way to program it is to use the analogWrite or analogWrite command. Let's see how we can use the analogWrite first. Alright, let's use the analogWrite command to control our Common Cathode RGB LED first. So in the void setup, we use the pin mode to set it up. Pin mode, we'll need to use the pin RGB LED is connected to. So you have to link it up. Let's create a variable above the void setup to link the RGB LED to. Let me use the red pin. My red pin will be pin 3. My green pin will be pin 5, and my blue pin will be pin 6. You don't need to use it like this. I'm just doing it like this because later we'll be learning about the analogWrite, and I want to be using pins with the pulse width modulation feature. Now, our pin mode, let's red, that's pin 3. An output, set it as an output because we're going to be outputting light, right? Let me just copy and paste for the green and blue too. Green and then blue. All right, now we come into the void loop. In the void loop, we can toggle each color off and on, and then we can also mix colors together to form certain secondary colors, like purple, yellow, and cyan. It's this kind of shade of blue, I guess. Now, here we use the analogWrite command to turn it on and off. Red, high, just set to high, which is an on to make it come on. And here is the thing: when you're writing a command, you have to write a command for every color: red, green, and blue. If I want only red to be on, I'll have to write green as an off. That will be a low. And then I'll have to write blue also as an off. What am I doing? Okay, blue as an off. So yeah, so red is on, green is off, blue is off. And let me add a delay. The delay pauses the code for an amount of time. It just makes it wait for a certain period, and I want that period to be 1 second, and it works using milliseconds. So 1000 milliseconds is 1 second. So now I've connected it to this variable wait, and I've put the wait there. Now so in this first example, the red comes on, and then while green is off, blue is off, so it's just red on. If I want, what did I just do? If I want only green to be on, I'd paste the code, change red to a low, green to a high, and blue I'll leave blue as a low. So now only green will be on. And if I wanted only blue on, I'll change red to a low and change blue to a high. easy as that. So over here red comes on, over here green alone is on, over here blue alone is on. Now if I wanted to mix the colors together, I can make two colors be on at the same time. Let me make this red is already on. Let me change green to a high, so green will also be on, and red mixed with green will give us yellow, right? Yep, I believe it will give us yellow. And then over here red, let me make a blue high also. Red mixed with blue will give us a purple. And over here let me change red to low, green to a high, blue to a high. So we have green mixed with blue, which will give us cyan. That's another color, kind of shade of blue. So yeah, over here it's red changes to green, changes to blue, then to yellow, then purple or magenta, and then to cyan. Yeah, so yeah, let me verify my code, just make sure everything is correct. Yep, it's correct. And if you upload it, your LED should turn on. Your LED should turn on. I would like to upload it, but then I don't really have the regular RGB Common Cathode RGB LED. I'll use this one I have. It's not the typical one you'd normally have, so then I can. But then if you have a Common Cathode RGB LED, it should work. I'm sorry I don't have that, but let me just show you guys the one I have. It's not very bright though. I think I fried it a while ago. Give me a sec. Alright, I told you all my LED was cooked. I've uploaded the code and it's not even that bright. Like I think I used it one time without resistors and well, did the result. So yeah, always use a resistor. I'd encourage you to always use a resistor. But if you have a Common Cathode RGB LED, it should work. Mine is even not really the usual kind you'd have, but it should work. All right. Let's just move on. Now let's learn about a Common Anode RGB LED. The Common Anode RGB LED has a common positive pin. That's the longest leg. The longest leg is the common positive pin. To the left of that we have the red pin. To the right we have the green, and next to the green we have the blue pin. This is how you can code it using the analogWrite. Alright, the Common Anode RGB LED actually works in a very different way than everything else we've worked with so far. Normally if you wanted to control an LED, you'd control the voltage, right? You just control the amount of voltage going to the LED. Or even if you weren't doing it, you just use the pulse width modulation to sort of create the illusion of it being like dimming or getting brighter. Or if you wanted to change a different color, you just send voltage to a different pin, like what we just did. If we wanted to make red come on, we'll send a high to the red pin. If we wanted to make green come on, we'll send a high to the green pin. So whatever we wanted to turn on, we'll send a voltage to that pin, right? We're using voltage to control it with a common cathode. With a common anode, it actually has one single positive pin. That's the longer one. And then the other three legs actually have their own ground. The others have their own ground. And then to control it, you're controlling it by controlling the ground. That's how you're controlling it. You're controlling each pin as a ground. I don't really get how it's working. I don't really get it, but that's how it's working. And the effect of that is the code is kind of inverse. It's kind of inverse because you're using the ground. You're using normally if you're using the 5 volts pin, it's a high, right? Because you're sending voltage, but this time it's a ground. So it's the ground. So then it's at a low. And that actually affects the code so much, because normally if we wanted the LED to come on, we would send a high. But this time is the inverse. So if we wanted the LED to come on, we'd have to send a low. That's it. It's everything is switched up. That's how the common anode RGB LED works. I hope you've understood. That's what I'm saying. All right. So basically, with the common anode, I'm just going to, if I wanted red to come on, rather than setting it to a high, I'd set it to a low and then set the rest of them to highs. Remember, it's kind of inverse. It is inverse because we are connected to a ground, because each pin is a ground. Each of the pins are ground. So each of them, we're controlling it by controlling the ground rather than controlling voltage. Normally, if we're controlling voltage and wanted to turn it on, we'd send a high voltage to it, right? We send a high to it. But then since we are controlling it with ground, it's a low already. So low is kind of to turn it on. Turn it on is sending a low. We're just varying the ground instead. All right. So now over here, if I wanted to turn green on, I'd make this a high, make green itself a low, and then make this a high. Because low is the ground. I hope you are getting the concept. High rather is off. Anyways, and over here with blue, low, high, high. Here red, high is off, blue is on. So then if I want these two on, low, and then this is high. So in this example, red and green are going to come on while blue is off. So yeah, that's how you can do the rest for the rest of the code. I don't really want to go into that because we're now even come to discuss analog writing in the same video, so I don't want to make it too long, but it's the same thing. You guys go ahead and just switch these two and then let me show you guys the result. Right, I actually have the common anode RGB LED and I believe it works properly. So let me upload it. If you ordered from my Temu link, then you'd probably have the common anode also. If you ordered from Amazon, you'd have the common cathode. All right, I think it's uploaded, and it goes red, then green, then blue, then yellow, then why isn't it coming on? Oh, forgot to disconnect it from ground and connect it to 5 volts. Okay, now it's coming. Oh my, it's too bright. You guys can't really see it, can you? Can you see the colors? Yellow, purple, blue, cyan, red, green, blue, purple. Okay, yellow, purple, cyan, red, green, blue, yellow, purple, cyan. I hope you guys can see the colors. Can you? But you see how it works. It's perfect. So yeah, all it's doing is using the ground to control it. An inbuilt ground in each of the pins. Yeah, I don't know why they'd make them so different. I mean, why didn't they just make one of them? If there is a specific reason, you guys drop it in the comments because I don't really get it. Alright, now let's move on. Alright, the next thing we're talking about is the analogWrite function. We'll be using the analogWrite function to be able to control the brightness of each color of the common cathode and the common anode. So let's start with the common cathode with analogWrite. Alright. If you know nothing about the analogWrite command, you can check out my previous video where I explain it in depth. To control the common cathode RGB LED, you will have to first of all set up our integer variables for the pins we are connected to. Red is pin 3, blue is connected to pin 5. Wait, no, green is in pin 5. Okay, I'm just, blue is in pin 6. Green is 5. Like that. Alright, and let me create an integer for the delay. And that will be wait 1 second, that's 1000 milliseconds. In the void setup, we use a pin mode too. Red output. The pin mode command is to set up the pins you are connected to. So I'm making it, letting it know we're connected to pin 3, that's red. And then we're setting it up as an output because we're going to use it to send out light. Pin mode. Then we'll do the same for green, also on output. Let me just, and you have to end with the semicolon. Don't forget that. And let me just copy and paste for blue too. Okay, and blue. Now we go into the, blue. Good, now we go into the void loop to write the code for each pin. Now we want the red to come on first, and we want to use the analogWrite command. That's like this, analogWrite. And we're writing to the red. And that's with the digital write, you can set it to a high or a low. With analogWrite, it's anything between 0 and 255. It's on anything on that range. 0 is off, 255 is the highest brightness, that's the maximum brightness, and then anything in between is any number between 0 and 255. You can pick anything at all and to come on at that specific brightness. If I want to come on at maximum brightness, let's put 255 and then analogWrite. So while red is on, I want the rest of them to be off. So green 0 and then blue 0. Let me copy and paste. Blue 0. Alright, so red is on. For how long? For 1 second, right? To delay. And I'm going to use this variable we created, the wait variable, which is 1000 milliseconds. 1000 milliseconds is 1 second, so delay for 1 second, that's 1000. Well, I'll have to use the variable wait, and I end it with my semicolon. Good. So that's for the red pen. If I hear the red pen comes on, everything else is off for 1 second. So red comes on 1 second, and then green, let me make green come on for 1 second. Green 255. Green comes on 1 second, and then blue comes on for 1 second. Okay, good. So then if I wanted to mix colors, I'd have to make 2 of them be on at the same time. So something like red 255, green 255. And then this is red makes the green will give us yellow. So it would come on as a yellow for 1 second. Red 255, blue 255. This will come on as magenta. And then red 255. Sorry, my bad. Red off, green 255, blue 255. When blue and green are on, we get yellow, right? Wait, no, blue and green, cyan. I'm sorry, cyan. So then, yeah, just by doing this, we can, let me verify our code and then make sure everything's good. I'll verify. Yeah, so that's it. Let me just do something. Since I don't have the the Common Cathode RGB LED. I'm just going to post it in to Copilot, Microsoft's Copilot, their AI, so that I can confirm how right my code is. So yeah, it's actually working. You see it's correct. It sets red to full brightness in the first, then green to full brightness, then blue to full brightness, and then both red and green to full brightness. That's for yellow, and then magenta, and then cyan. So yep, you just cycle through this color. So yep, we are correct. Let's focus on the Common Anode RGB LED now. Now once again, with the Common Anode RGB LED, you have to actually invert the code like we did with the analogWrite. Low is high and high is low, because this time we're working with the ground. So now, if we, like we did with the analogWrite, if we set it to a high, it goes off. If we set it to a low, it comes on. It's the same with this one. If we set it to 0, with 0, it comes on at the highest brightness. And with 255, which is the highest brightness, it goes off. So then it's inverted, and it's the same thing for everything in between. So this is how we're going to get around that. We're going to use a certain method. We just subtract everything we want to. Now let's just get it. I'll explain while we write the code. Alright, now for the Common Anode RGB LED. The Common Anode RGB LED is a bit different to program. With that one, you have to once again invert. Use the inverse number, like the opposite, I guess. If you wanted to set it to a low, you have to set it to a high. If you wanted it to come on, you have to give the command for off. So with the analogWrite command, is basically the same. If I wanted to be a 0, I'd have to set it to 255. If I wanted it to be 255, I'll have to set it to a 0. And then it's the same for the in-between numbers too. Let's go. I closed the window. I was choosing to write the first program, so I'll have to just rewrite it all again. I could just skip this part for you guys. I think I'll do that. Pin 6. And now here for the pin modes. Pin mode. Red. Output. Close. Okay, let's just all right, now that we're done setting up the pin modes and the variables, now we can come into the void loop and start using the analogWrite to control our RGB LED. So red pin, let me write the command. So first of all, I want the red to come on. Red alone should be on. And normally if I wanted it to come on, I'd have to put a 255 here. But this time I don't want it to come on. This time I want it to come on, but I won't put the 255 here because I was using a common anode, I'm sorry. I was using a common anode. So rather than putting a 255, I'll put a 0. And it's going to turn it on at the highest brightness. 0 is basically like 255. It's very different with the common anode. So then analogWrite. I want the other ones to be off. green. I want green off. And normally I'd put a 0, but this time I put 255 to turn it off. And let me copy and paste for blue. So blue 255 is supposed to be high, but then in this case it's off. Then put a delay. Yeah, so it's basically like this. This is basically the rundown. Control V. Let me make red go off. Let me make green come on. So green will be 0 and this will be 255. In this case, 255 is rather off. It's a bit complicated, but yeah. Now I don't want to, let me just show you something else. Here is the thing. If I wanted to use an in-between number, like one between 0 and 255, rather than the very end and then the very beginning, if I wanted something in between, like for example, 120. If I wanted to use 120, I'd have to subtract that from 255 and then use the value, the result I get. Let me show you guys. So then if I wanted it to come at the brightness of 120, rather than just putting in 120 like that, I'd have to subtract it from 255. And once I subtract it from 255, the answer I get is what I'll use to give me a result of 120. So then 120 minus 155 at 135, right? I believe so. Okay, so I subtract, and this is what I'd actually put in. But then the result I'll be getting from the LED is 120. The result I'm getting is 120, even though in the code, I put this in the code. Because this is basically the inverse of it. I hope you guys understand. Alright, so then if I wanted a result of 120, I'd have to put in 135. Let me just paste. If I wanted, okay, this red, you know, green, over here red comes on, over here green comes on, over here blue is going to come on. So let me put this at 255 and then change blue to 0, right? Now in the next one, let me put the 135 in that one just to give you the, explain what I mean. If I wanted this to come, red to come on again, but then at 120, rather than putting 120 in there, I'll put 135, and that's like 135. Yeah, so then I'm having 135 in my code, but the result that will be shown on the LED is for 120, which is the inverse. So just subtract your main goal from 255. Just subtract from that, and then whatever you receive as your output is what you'd actually want. Is the inverse. Just the inverse of what you put in the code. So just keep that in mind. It can get tricky a bit sometimes. So keep that in mind and you'll be fine. And let me think green on. So it's green mixing with red. That is going to give us yellow, right? And then blue is off, 255. It's supposed to be on bar inverse. And let me just upload it like that. I don't want to just keep too long. Let me show you guys the RGB LED. Alright, so here we have my RGB LED. It's already on, but I've not uploaded the code we just wrote. Let me upload it right now. Okay, uploading. Yep, it's, let me put this over red, green, blue, yellow. It's not yellow. Yep, now you see it's better now. Yep, you can see the yellow, you can red, green, blue, yellow. So yeah, that's how it works. If you want to adjust anything, you can do that in your code. It's not too complicated. Hope you guys have a wonderful rest of your day. If you've not checked out my website, feel free to do so, link in the description. Yeah, I'll see you guys in the next one.